Okay, let's talk about factoring numbers. A factor is simply a number that, when multiplied by another number, gives you the final number. Let's factor 12. Oops, wrong brush, wrong tool, 12. We ask the question, what times what equals 12? 3 times 4 is one answer. 3 times 4 equals 12. Then we're making a factor tree. It's actually an upside down tree. Now we ask the question, what times what equals 3? Well, we only have two choices. 1 times 3 equals 3, or 3 times 1 equals 3. Well, yeah, it's the same problem. We've just flipped the order. Remember, we can flip the order because of the commutative property and get the same answer. If this is true, when a number only has a 1 or itself as a factor, then it's called prime. Prime numbers are the leaves of a factor tree. Here's the branches, and prime numbers are the leaves. Well, 4 is not prime. You can multiply 2 times 2 to get 4. If it's not prime, if a number is not prime, it's composite. And of course, we're only talking whole numbers, not fractions and others. Just when we talk about primes and composite numbers, we're talking about the set of whole numbers. 2, you can only multiply 1 times 2. Only 1 and itself are the factors. So if 2 is prime, 4 is composite, 12 is composite. That's the factor tree for 12. Let's look at the factor tree for 15. Remember the earlier problem, we had 12 fifteenths? We're going to learn how to simplify this using factor trees. 3 times 5 is 15. 3 we already know is prime. Does 5 have any other factors besides 1 and itself? The answer is no. We can't multiply 2 times 3 to get 5, or 3 times 2, or, there's nothing else that we can multiply together to get 5 except 1 and itself. 5, only 1 and itself are factors of 5. So 5 is prime also. Now we use a construction called a Venn diagram. John Venn was a famous mathematician in the 19th century. This diagram is used all over the place. It's used in English, it's used in philosophy. They don't know John Venn invented it. They don't call it a Venn diagram. But that's what it is. He invented it. It has to do with set theory. And that has become so popular in every field. Everything that we deal with. Venn diagrams are all over the place. Basically, what it is, this circle here is going to be the set of factors of 12. This circle here, or potato-shaped object, is going to be the set of factors of 15, of prime factors, of the prime factors, the ones we've circled, prime factors of 15 and 12. This thing in the middle, if a number is a factor of both 12 and 15, we're going to put it in the middle. That's called the intersection. It's given a symbol, an upside down U. So 3 is a factor of both, so we'd put it in here. 2 is not. 2 is only a factors. 2's are only factors of 12. And 5 is only a factor of 15. This is called a common factor. So we can take 12 divided by 3. We can take this fraction. We found the common factor. In fact, 3 is what's called the greatest common factor, the largest number that is a factor of both 12 and 15. A factor other than 1, by the way. Greatest common factor. A factor other than 1 that goes into both the numerator, the top, and the denominator, the bottom of a fraction.